All right. So, hello, grade 10s. This is Mr. Musklow, and I've become a little bit of a YouTuber because this is actually a YouTube video that was included with today's material. In normal circumstances, I wouldn't do this. I wouldn't include a video recording of me giving lessons as part of the supply plans. But just with the circumstances, since I'm isolating for a few days, I thought that it would be helpful for me to include some videos of me just explaining the material because I know that spending 3 days straight just doing independent work can be kind of annoying. So this is just the next best thing to having me actually in class in front of all of you teaching this stuff. Just having some videos of me explaining the material. So we're just going to run this like we usually do. I have some PowerPoints and there's going to be some questions that you'll be working on today. And this PowerPoint is on characteristics of an image and reflections from plane mirrors. So we talked earlier in the week about the laws of reflection, and we're going to use that knowledge to better understand how images actually form in mirrors, which I know may seem like a bit of a weird topic, but we'll see that it's actually not as straightforward as you might think, particularly if we're dealing with mirrors that are curved in some way instead of flat. And yeah, that's basically the subject of this PowerPoint. And the next PowerPoint is about converging mirrors specifically, and then the one after that is about diverging mirrors. All right, so let's talk about characteristics of an image first. Whenever you see an object reflected in a mirror, you're of course not seeing the object itself. And so this is just a picture of the mirror on a vehicle. And the point is, when you're looking into this mirror, you're of course not actually seeing this hill and this road inside the mirror. You're just seeing an image, and this image is created from the light reflecting off of the mirror. And so an image basically is a picture of the object that's produced by light. Okay, this image is being created by light reflecting off the mirror. Now, scientists use 4 characteristics to describe a reflected image. And so we're going to talk a bit about each of these 4 characteristics in this PowerPoint. And it might not really be clear exactly what some of these mean until we start looking at mirrors that are not flat. And so I'll explain what I mean by that in a minute. But for now, I'll just say SALT is a way of remembering these 4 characteristics. So SALT is spelled S-A-L-T. S stands for size, A is for attitude, L is for location, and then T is for type. So we'll start out with size. So the size is simply how big the image is. Is it larger, smaller, or the same as the actual object itself? The attitude is whether an image is upright or upside down. Now, from your everyday experience of just looking at your own reflection in a regular flat mirror, you would find, of course, that your image is upright. You would also find that the size would be the same. So the size of your image in a flat mirror is not larger or smaller than the original object. So it may be kind of strange to imagine a case where the image would be upside down, but we're actually going to see that in certain types of mirrors, the image produced is actually an upside down mirror. And it's a converging mirror in particular that produces an upside down image. You would see this actually if you've ever paid attention to your reflection in a spoon. So a spoon is actually an example of a converging mirror, as we're going to see. And you might not have ever noticed this before, but if you look at your image in a spoon, the image can actually be upside down. So that's what we mean by attitude. It's simply whether the image is upright or upside down. Now, the location of the image refers to whether the image is behind, in front of, or on the surface of the mirror. And again, that idea might seem kind of strange, but we're going to see that there are mirrors that create images that are actually in front of the mirror, for example, or on the surface of the mirror. So we'll talk more about location soon. You don't need to worry too much about that now. And then the type is a characteristic that students often find confusing. We are going to talk more about this shortly. I'll just tell you for now, though, what the definition is of a real image and a virtual image. So a real image is formed when light rays actually meet at the image. So we're going to see what that looks like. A virtual image is an image formed in a location where light does not actually reach. And so that means that the light only appears to come from that location, but it doesn't actually reach that location. So what the heck does that mean? What does that actually look like? Well, this PowerPoint is only looking at reflections that take place for flat plane mirrors. And this is a ray diagram showing how the image is created for a flat plane mirror. And so I'll just explain exactly what's going on in this image, and then I'll explain why this particular type of image, it turns out, is a virtual one and not a real one. All right, so we have our object here. Could be any object. The object that's often chosen in the textbook for the purposes of drawing ray diagrams is a candle. Okay, here they just draw it as a point. Let's say it's a candle. So this candle is going to emit light rays in every direction. And you can see that the light rays, when they hit the mirror, they reflect, of course. And we talked about how the law of reflection says that the angle of incidence equals the angle of reflection. And so this is what the path of the light rays look like. They hit the mirror, they reflect, and they reach this individual's eyes. Now, if the light rays are hitting this individual's eyes in this way, their brain is going to trace the source of these light rays to be behind the mirror. Okay, to this person's eyes, it looks like these light rays are actually coming from over here, because if the object was over here, it would just produce light rays that meet the eye like this. And so this observer is going to see an image that appears to be in this location. But is the image actually in that location? Well, no, it's not. It's actually over here. It appears to be coming from here. And in particular, the object appears to be in a location that you can't actually go to. So this object is coming from behind the mirror, and you can't actually go behind the mirror, right? If you've ever looked in a mirror before and you see your image like inside the mirror, you can't actually go there. And so this is why it's a virtual image. It's basically because you can't actually go and meet this image. It's coming from behind the mirror, and you can't go behind the mirror. So that's what makes this image virtual. And if we actually just go back to our original definition, it says a virtual image is an image formed in a location where light does not actually reach. The light only appears to come from this point. Okay, and so the light is only appearing to come from here. The light doesn't actually meet this location. It only appears to, and that's why this is a virtual image. Okay? Now, often what we do when we draw ray diagrams is we want to make a drawing of where the image will actually be. And so you can see in this slide that the virtual image is here. It's an equal distance away from the mirror as the object is. So you can locate the image using the laws of reflection, just by drawing the light rays reflecting off of the mirror like this, and then kind of tracing the light rays back to their source. But there's an easier way to draw the image that's created with a flat plane mirror. And that's what this second slide shows. So this is locating the image using geometry. And using geometry is very simple. The idea is just that you look at how far away the object is from the mirror. And then the virtual image has to be an equal distance away from the mirror. Okay, and in particular, when we want to determine the distance from the object to the mirror, you can see we're drawing a line that's perpendicular to the mirror here. Okay, so this is a 90-degree angle. This is quite simple if our object is simply a point like this, but let's see how it works if we're dealing with an object like a pen. Okay, so this is our object, and we want to know what the image is going to look like. So where this virtual image is going to be located in the mirror. So again, it's pretty simple. You just look at how far away different parts of this object are from the mirror. And then the virtual image is an equal distance away on the other side from behind the mirror. And so this cap, for example, is this far away from the mirror, and this line segment has a length that's indicated with this tick. And so this line segment has the same length. That's why it also has one tick. And so this part of the virtual image is the same distance away from the mirror. Okay, so that's how we draw virtual images for flat plane mirrors. Now, you are going to have an opportunity to practice drawing some images that are created from flat plane mirrors. And you might think that this is really quite a simple thing to do, but students sometimes get mixed up whenever they're drawing the reflected image. And for example, they might make a mistake where they draw the virtual image as being at an angle like the original object is. So they would draw the virtual image as being at an angle like this, which is not correct. So we just need to be careful and make sure we understand that the virtual image is always an equal distance away from the mirror as the object is. Okay, so you have an opportunity now to just practice drawing some virtual images. This would be the point in the PowerPoint where I would ask if anyone has any questions, but I can't really do that because this is just a video. Okay, but of course, if anyone has any questions, you can ask the supply, or you can always reach out to me as well.